In this problem, a mass connected to two springs, as shown here, is pulled some distance a from its equilibrium position and then released. The mass begins to oscillate back and forth, and it's noted that its maximum velocity is 5 meters per second. We were asked to find the amplitude of this accelerate motion. In order to solve this, we're going to use energy conservation. The first things to note, though, are that the spring constant of this spring is 10 newtons per meter squared, the spring constant of the second spring is 20 newtons per meter squared, and if we combine these two springs into one, the effective spring constant would be 30 newtons per meter squared. We are going to want to find the maximum potential energy and the maximum kinetic energy of this mass spring system. The maximum potential energy occurs when the mass is the furthest it can be from its equilibrium position. That is, when delta y, the absolute value of this, is equal to A. Substituting in this expression into the equation for potential energy, we see that the maximum potential energy of the spring mass system is therefore equal to 1/2 times the effective spring constant times the amplitude squared. The maximum kinetic energy occurs when the mass is traveling at its maximum velocity. Therefore, the maximum kinetic energy is equal to 1/2 times the mass times its maximum velocity squared. Setting the maximum potential energy equal to the maximum kinetic energy and simplifying and then solving for the amplitude, we see that the amplitude is equal to the square root of the mass divided by the effective spring constant times the maximum velocity. Plugging in numbers and evaluating, we find that the amplitude of the oscillation is then 1.58 meters.